Hello everyone, so now I have this claim. I have this claim that the mth Fibonacci number is equal to the sum from k equals 0 over the floor, m minus 1 over 2, m minus k minus 1, choose k. And the reason I threw this floor on here is if I divide by 2 and I get a remainder of 1/2, I can't go past that. I'm going to stop at the integer below. So I want to test this with just by doing some calculations. Of course, you could test this on a computer, and if you want to write a program real quick to test this, be my guest. I think it'd be awesome. But I'm going to test it. So I know over here that f of 2 should be equal to 1. And over here I'm going to say, what is the sum from k equals 0 to the floor of 1 minus 1 over 2 of m minus k minus 1, choose k. So 1 minus 1, choose 2 is equal to the floor of k equals 0 to z. I'm sorry, it's the sum from k equals 0 to 0. M, in this case, m is equal to 2. So I'm looking at 2 minus k minus 1. Choose k. Now when I sum from 0 to 0, there's only one term. So that's equal to the sum from, well, I can just go ahead and say that's equal to 2 minus 0 minus 1, choose 0, which is equal to 1, choose 0, which is equal to 1. So that worked out. Let's test another one. I know that the next Fibonacci number, f of 3, should be equal to 2. So I'm going to say, what is the sum from k equals 0 to the floor of 3 minus 1 over 2 of 3, because in this case m is equal to 3, minus k minus 1, choose k. So 3 minus 1 is 2, divided by 2 is 1. So this becomes the sum from k equals 0 to 1 of 3 minus k minus 1, choose k. And I'm going to have values here for k equals 0 and k equals 1. And so I'm going to get the sum. I'm going to get, okay, when k is equal to 0, this is equal to 3 minus 0 minus 1, choose 0, plus 3 minus 1 minus 1, choose 1. So this is equal to 2, choose 0, plus 1, choose 1, which is 1 plus 1, which is 2. So it worked there as well. And if you keep doing this, I mean, this formula is correct unless we made a mistake in our earlier algebra or reasoning. But because we know that this was a way of writing the coefficients on the x to the m term, it must be equivalent to the other way. So this identity must hold unless we made a mistake, which I don't think we did. I think we were good. However, if you're worried about making a mistake, you could prove this by induction on m. So I think it's a cool thing to do to write a program that would test this. You could write a program called, altfib, or a function called altfib of m that calculated this and see if it matched the Fibonacci values you were expecting. But instead, what I think we can do instead is prove it by induction. So let's try that in our next video.